Yesterday I did a question where I proved that a quadrilateral is cyclic, right? And I used the converse of theorem 4 to prove it. Remember, there are three cyclic quad theorems. You need to sanitize. There are three cyclic quad theorems. Okay? Angles in the same segment, opposite angles of cyclic quads are supplementary. Sorry, you are supposed to sit where I told you to sit.
Around people, she can't see.
Hey, listen, you are supposed to sit where I told you to sit.
Around people, sir, you need to spread around.
Please, it's your first day to come. Since we last talked about 2 weeks ago, can you please sit where I told you to sit?
You're gonna get drunk or something.
The question, okay, you can read the question that says, prove that EF is parallel to AB. Now, this question has got cyclic quads, right? Now, if you want to prove that lines are parallel, you must prove that they are corresponding angles, therefore they are equal, therefore those two lines are parallel. You can also prove that the angles are co-interior. If you prove that two angles are co-interior, which means if you prove that two angles, if they are added, they add up to 180, then you can say therefore EF is parallel to AB. Lastly, if you can prove that they are alternate angles, means the angles are equal, then you can conclude that the lines are parallel. So there are three ways of proving that lines are parallel. Either you can use alternate angles being equal, corresponding angles being equal, or co-interior angles being supplementary. Okay? So here,
Sir, can we open a window or door or something to the fan?
I opened the windows. Can you open some of the windows this side? Here, I expect you to check out your maths workbook. I don't have to tell you that. You need to open your maths workbook. You write today's date and write that, how to prove that quadrilateral is cyclic. Now, in this case, I'm going to change this. So, here, the way that I'm going to prove, right? First thing, by now, you all know the theorems of cyclic parts. Right? So, I have this angle, that's C1. C1 is an exterior angle of cyclic part CDEF. So, it's equal to that angle. Right? At the same time, this angle C1, if I add it to angle A, I'll get 180 degrees. Okay? Based on theorem 5. So I'm going to use theorem 4, so theorem 5 and theorem 6 to prove this. So my first step is to say angle C1 is equal to angle E. And why? Because they are exterior angles. Okay, exterior angle of the exterior angle of the cyclic quad. Okay? Angle C1 is equal to angle E. That's theorem 6, exterior angle of cyclic quad. Then, I also know that angle C1 and angle A, they add up to 180 degrees. Opposite angles of the cyclic quad add up to 180. So, C1 is equal to, so C1 plus angle A, they add up to 180 degrees. And here I'll write here opposite angles of cyclic quad. Alright? Okay, I hope you can see that. Now what this means is I can write this and say therefore, I'm sure you can see that we have got C1 here and we have got C1 there. I hope you can see that. In both statements or equations, we have got C1, which means where we have C1 in the second equation, I can substitute the C1 by angle E. So I can write it therefore angle E plus angle A. Okay? So we are talking about this angle here and that angle. They add up to what? To 180 degrees. Therefore, EF is parallel to AB. Okay? Why? Co-interior angles. Co-interior angles are supplemented. SUPP. Or we can say they add up to 180 degrees.
So why don't you just put GO dash I and T?
Put what?
Instead of writing the whole interior, why don't you just
No,
put in
it's based on examination guidelines. You are supposed to write it like that. Okay? I hope I told you about, I gave you a copy of the examination guidelines. I posted it on the group a long time ago before we closed. Anyway, so when you are proving that lines are parallel, this is how you do it. Right? It's 5 marks. Okay? 5 marks. So you obviously get, I think the mark allocation, if I'm the examiner, I'll give a mark here. Mark for that reason, mark for that reason, mark for this, for that statement, and the mark for that statement. Then you get 5. Okay? So that's how you prove that 2 lines are parallel. Okay? I'm going to give you homework later on in the day. Okay? So today I'm going to introduce the tangent theorems. Okay? Today I'm going to introduce the tangent theorems.